Hello, in this video I'm going to be talking about momentum. Specifically, I'm going to be defining momentum as well as exploring the relationship between force and momentum. So first, to define momentum, I would define momentum as a given vector which measures the how hard it is to stop a moving object. So the symbol for momentum is like this. And the formula to determine momentum is equal to mass times velocity. Now I'm going to go ahead and talk to the relationship between force and momentum. So the rate at which an object's momentum changes is directly proportional and in the same direction as the applied force. This can be given by the following mathematical formula. So force is equal to the derivative of momentum, which is also known as the derivative of m times v, given the formula above. So now that we've established that, I'm going to go ahead and apply these two concepts to an example from the AP Physics practice multiple choice section exam. So I'm going to be looking at number 27, and I'm first going to read the problem out loud. The graph above shows a variable force F that acts on an object as it moves along a straight line as a function of time t. What is the change in the momentum of the object from t equals 2 seconds to t equals 4 seconds? So I'm going to go ahead and draw the graph up on the board. We've got our y-axis here, which represents the force, which is in newtons. And then we've got our x-axis here, which represents time and which is in seconds. We've got a gridded graph. I'm just going to do a rough estimate here. 1, 2, and 3. 1, 2, and 3. So we've got 1, 2, 3, 4. And 1, 2, 3, and 4. And the graph in the diagram on the problem looks just like this, which is representative of the force applied to the system. To the applied force on the object. So it is asking what is the change in momentum of the object from t equals 2 seconds to t equals 4 seconds. So from here to here, it would like to know the change in momentum. So we can use this formula above that we have for force that states that force is the derivative of momentum, and we can take the opposite of derivative to say that the momentum is equal to the integral of force, which also means that momentum is equal to the area underneath the force curve. So that would, if we're looking at here, what the problem is asking for essentially is the integral, the definite integral from 2 to 4 of force, which is just this area right here. A simple way, very easy, you can just multiply 2 times 2 is 4, so that's area here, area 1 equals 4. Just to specify, this is calling this area 1, then area 2 is going to be 4 divided by 2, which is equal to 2. Area 1 plus area 2 is equal to 4 plus 2, which is equal to 6. And we see if that corresponds to any of our responses, and it does. Oh, and I forgot to add the units, which are kilograms times meter per second, which corresponds to option D on the exam. Thank you.